Welcome, class, to the online portion of your class, which is the lecture. And once again, we have a live audience with us today, a live student audience. And additionally, we have a special guest, Dr. Charban Romanku. Did I get that right, Doctor?
Да, правильно, все правильно.
Good. And also we have a translator, Vladislav Gafinko. And Dr. Charban is an expert in the field of gravity, no pun intended. And he will be chiming in occasionally during this class to enlighten us, no pun intended. Okay, now to begin, the history of gravity is marked by many misconceptions. We'll start once again with Aristotle's misconceptions because his are the most fun. So Aristotle, if you guys remember correctly from last class, who maybe one of you remembers in my live audience, what was Aristotle's biggest scientific error that plagued all of his physics? Yes, Nicholas.
Was it the one about gravity pushing?
No, that was just a detail. This is a broad, sweeping mistake. Do you remember, Andre?
No, I don't.
Okay.
No.
Dr. Charban, maybe you could say something about Aristotle?
Я думаю, что Аристотель, он на море ходил каждый день и плавал в море, и ему это очень нравилось, так что он купил сандалии.
Okay, Vladislav, could you translate for us? Yes, what Dr. Charban is saying to us is that his largest mistake is that rather than basing his physics on experiment, on one hand, on modern science, we have experiment for all scientific evidence. Rather, Aristotle simply make assumption. He make assumption about the thing he's trying to describe. And then, rather than check assumption, he never check assumption with experiments. So simply you have assumption, and therefore all of Aristotle's physics is mistaken. And basically, we call this philosophical word is a priori. You might see this Latin word in some textbook, and basically means that you assume something beforehand rather than actually determined by experiment or equation or something like that. Thank you, Vladislav and Dr. Charban. So, class, this is very, very well described. Basically, this was Aristotle's mistake. He simply assumed stuff and then teaches it, and it was held in the West for basically, 1,500 years, very rigidly, where there was no experiment ever done. So let's talk about one of these a priori assumptions of Aristotle. And again, this is the biggest mistake in gravity, which is that the mistake is that heavy objects fall faster, right? That is the assumption. Now, this is a little bit confusing because a lot of times this is true, right? Thea, could you give me an example when something heavy falls faster than something light?
An anvil.
Yeah, excellent, good. So this is where things get tricky because, Aristotle wasn't completely wrong. If you have an anvil, try to draw one here. It looks like the Chicago Bulls. Okay, it's an anvil. Sorry, I don't know. I tried. Here, let's work this a little bit better. Let's just do a bowling ball. Okay. Yeah, bowling ball. There's a bowling ball. That's good. And here's a feather. Right. In our everyday experience, the feather falls very slowly, but the anvil, or the bowling ball, goes down extremely fast. So Okay, so Aristotle's not wrong in this case. But if you replace the feather with, say, a plastic ball that's maybe half the size of the bowling ball, they're going to fall at roughly the same speed. Okay? So there's no easily discernible relationship between the mass of an object and how fast it falls when you're in Earth's atmosphere. So, so Aristotle, just based on basic observations, made this statement as kind of a blanket statement to describe gravity. Heavy objects fall faster. Well, Galileo came along and showed she showed experimentally that this is not true. And of course, there's the famous story. We don't know if it's true or not. Let's just assume it's true because it's more fun. That Galileo he dropped things off the Leaning Tower of Pisa to show that indeed it doesn't really lean quite that much, but you know there. Oh, really? The building is curved.
It was leaning, so they compensated on the bottom to make it.
Oh. Wow. Okay, I didn't know that. But anyway, there's our Leaning Tower of Pisa, and here is Galileo. And he's dropping stuff, and he shows very definitively that a heavy object and a very much lighter object hit the ground at the same time. Okay? So he shows that Aristotle is wrong with evidence, and he gets in trouble for it because this was the beginning of what is known as the scientific revolution, which is that any understanding of physical phenomenon has to be backed up by experimental proof of some kind. Before this was not really understood. Okay? So he shows that heavy objects fall, or all objects fall at the same speed, but that lighter objects, such as feathers or balloons, are interfered with by two forces, not just one. What do you, just in your everyday thinking, what slows a feather down? Yes?
Air resistance.
Air resistance, very good. But I'm wondering if Dr. Charbon could share with us a little bit more about the forces that act on a falling object in the atmosphere.
Да, я когда был в Судаке, у меня был хороший друг Кири, и мы с ним ходили по горам.
And Vladislav, if you could interpret that for us. Yes. What Dr. Charbon is saying is essentially that there are really two separate forces acting on falling objects. The one is the one that we're all familiar with on an everyday basis. For example, here is a balloon. And balloon is filled with air, not helium, and begin to fall. And as balloon fall, it gains some speed, but then it slowed down to it, or rather it accelerates to some speed and then maintain that speed, and that speed is known as terminal velocity. So it reaches terminal velocity and then continue to ground at that speed, right? Well, terminal velocity occur when the force due to gravity, which is going down, and it is vector force, so we draw a symbol on top, and the force due to air resistance, force R for resistance, when F R equal Fg, at that point no more the forces are balanced and the balloon continue at fixed or constant velocity downward. Right. So that is the equation for terminal velocity. However, there is additional force acting on balloon. And this explains why, for example, balloon may fall more slowly than feather or other things like this, which is that there is additional force known as Archimedes force. Archimedes force. And the Archimedes force is the force due to the displacement of the fluid that object is in. We are most familiar with Archimedes force by using term or expression called buoyancy. Very strange. Archimedes force, also known as buoyancy. So, Father Joshua, why don't you continue with explanation? Yes, thank you, Dr. Cherban and Vladislav. So, as Dr. Cherban was explaining, well, we're going to stop this particular video, and we'll pick up with the next one because we're going to run out of time here.